Hello student, in today's class we are going to discuss the strategy of preparing the number system for SSC CGL exam. So there is a disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Now see the indexes which we are discussing in this lecture. So first one is common question about number system, study guide for number system, 10 days study plan for number system, previous year question papers, questions and some common mistakes to avoid, and expected weightage. And at last we will see the trend analysis last 5 year, how many questions asked in SSC CGL from the number system topic. So first we discuss the common questions about the number system. When preparing for the number system section in quantitative aptitude paper for SSC CGL exams, students often have several common questions. Here are some typical ones along with the brief answer. Now the first question is, what are the most important topic in number system for SSC CGL exam? So answer is classification of number, in which natural number, whole number, integer, rational, irrational, real we are all discussing. Second one is divisibility rules, is important in SSC CGL exam. SCF LCM, concept, word problem, application based. Remainder theorem based question, cyclicity of numbers based question, unit digit based questions. Fraction and decimal, simplification and comparison based questions. Prime number, co-prime number, twins prime number based questions. Number of factors, factor based question, in which number of factors, sum of factor, perfect square and cubes. And surd and indices. So these are the important topics in number system. From there, the question asked in SSC CGL exams. Next one is, which book should I refer to the number system? So quantitative aptitude for competitive exams, you can choose fast track objective arithmetic, SSC mathematics, NCERT mathematics from class 6 to 10th for fundamental concept, especially 6 to 8 for number system basics. SSC CGL previous year paper to use to understand the question pattern which are asked in SSC CGL exam related to number system. Next one is, should I revise NCERT for number system? So yes, NCERT from 6 to 10th is excellent for clearing fundamental concept like types of number, divisibility rules, LCM SCF, fraction and decimals, prime factors. Focus on class 7th and 8th NCERT for number system basics. So next one is, what are some common mistakes students make in number system? So first one is confusing between LCM and SCF, application in word problems. Second mistake student did, misapplying divisibility rule, mixing up rule for example 4 and 8 rules. Ignoring unit digit cyclicity. For example, in remainders problem, student many times ignore the cyclicity of the unit digit. Overlooking negative numbers in integer based questions. So many times students overlook the negative numbers in integer based question. So avoid these type of mistakes. Error in simplifying surds and indices questions. So many times students did the wrong calculation in surds and indices question. So please avoid this type of errors. Next one is, how can I improve my speed and accuracy in number system? So the answer is memorizing divisibility rule. This is the most important, especially 7, 11 and 13. Practice shortcut method, finding SCF by division method, for example. Solve previous year SSC CGL question. Repetition help in pattern recognition. it will help you to recognize the pattern between the questions. Take time quizzes to improve speed. Next one is, how many questions come from number system in SSC CGL exam? So usually 2 to 3 questions per paper in tier 1 and tier 2 if we are talking about both the tier. So maximum 3 question, minimum 1 to 2 question asked in tier 1 and 2 to 3 question in tier 2 exam. More focus in tier 2 in quantitative aptitude in number system topic. Which YouTube channel or online resources are the best for the number system? So Sathi SSC, you can choose it. This is our web URL for English, and this is our web URL for Hindi, and this is our Sathi app. So please download the app using given link. Then how to register or create account on Sathi for SSC CGL? So there is a procedure. So please follow these steps to register or create account. So first one is click on the following link and select sign up. Then fill your detail and click on submit. Check your email and password reset link. Next one is click on the link and set your password. After that, click on the following link again. Enter your email ID and password. Now you are ready to start your learning journey. So you can use the Sathi website and Sathi app to learn the best way to number system topic for SSC CGL exam. Now the final tips. So practice at least 50 to 100 question from each subtopic. So when we're talking about the each subtopic, so we are talking about the, for example, LCF, LCF, remainder, divisibility, factors, unit digit, number of zeros, all these topics of number system. Revise formula weekly to retain them. Now we move to comprehensive study guide for number system. So the number system is a fundamental topic in the quantitative aptitude section for the SSC CGL exam. A strong grasp of this topic help in solving problem related to arithmetic, algebra and data interpretation. So the classification of the number. First we discuss about the classification of numbers. So A is type of number. So first one is real number. So as we know that all rational and irrational number are known as real number. Now second one is rational number. So we know that a number which can be represented or expressed in P by Q form where Q should not be equals to 0. So we can say that number is a rational number. For example, 3 by 4 minus 5 by 2 all are rational numbers. Next one is irrational number. So those number which cannot be expressed in P by Q form, we can say that those numbers are irrational number. For example, root 2, root 3, root 5, pi, all these are the irrational numbers because we cannot represent into P by Q form. Next one is integer. So all positive and negative numbers all called integers. So minus 2, minus 1, 0, 1, 2 up to infinite, minus infinite to plus infinite. So integer we can break it into positive integer which contain 1, 2, 3, 4 up to infinite, negative number minus 1, minus 2, minus 3 up to infinite, and non-negative integers, or we can say that we include 0, 0, 1, 2, 3 up to infinite. Now the fifth one is natural number. Now natural number are all positive numbers. So we choose from 1 to infinite. From 1 to 3 all positive numbers up to infinite. Whole number, we include 0 in natural number, then those number are called whole number. So we start from 0, 1, 2, 3 up to infinite. Those number are whole numbers. Prime number, a number with exactly two distinct factor is known as a prime number. So we know that those number who have exactly two distinct factor. So for example 2, 3, 5 and 7. So as we know that one is not a prime number. Okay, because one don't have two factors, one have only one factor. So we can say that one is not a prime number or a composite number. So smallest prime number is 2, and 2 is a only prime number who is even also, because we know that even number is those number who are divisible by 2. So 2 is only a even number who is prime and a even. So composite number, numbers with more than 2 factors are called composite number. For example, 4, 6, 8, 9, 10, 12, any numbers which have more than 2 factors. Next one is co-prime numbers. So the co-prime numbers are those number whose two numbers whose SCF is 1. For example, 8 and 15. So that their highest common factor is 1. 1 is the only number which can divide 8 and 15 both. There is no any other number who can divide the 8 and 15. So any two consecutive number will always be co-prime. So for example, you can take it 2 and 3, 3 and 4, 4 and 5, 5 and 6, or any one you can choose it, 11, 12. They will always be co-prime to each other. Even and odd numbers. So B1 is, even is those number which is divisible by 2. We know that. So 2, 4, 6, 8, 10, 12, etc. All these number are even. And odd number, which number are not divisible by 2. For example, 1, 3, 5, 7, 9, 11, 13. All these numbers are called odd numbers. Now see property of numbers. So sum and, or we can say difference of two even number will be always even. In the same way, sum and difference of two odd number will always be even. Sum or difference of one even and one odd number will always be odd. Product of two even number will be always even. Product of two odd number will be always odd. Product of one even and one odd number will always be even. Now see some examples related to these properties. So sum or difference of two even numbers. So we can take 6 plus 4. So when we add up two even number, we got 10. And when we subtract 6 minus 4, we again got a even number. 2 is a even number. In the same way, sum or difference of two odd numbers will always be even. So take two numbers, 5 and 3. So 5 plus 3 will become 8. This is an even number. And when we subtract it, 5 minus 3, we again got 2, which is an even number. Same way, sum and difference of one even and odd number will always be odd. Now, if we take 2 and 1 as an odd number, so what we get? We always got an odd number. Now when we subtract it, 2 minus 1, then we again got an odd number. In the same way, the product of two even number will be always even. So 2 into 4 will become 8, which is even number. Same way, the product of two odd numbers, so take it 3 into 5, which becomes always 15, which is always an odd number. Same way, the product of one even and one odd number is even. Now we can take it as an example, 3 into 2. What we get? 6. It is an even number. Now again we can take it any odd number, which is 11 multiplying by 4, even number. What we get? The result will be always even. So 44 is an even number. Next. Divisibility rule. So these are the divisibility rule of 2 to 11. So we know that a number will be divisible by 2 if the last digit of any number is 0, 2, 4, 6 and 8. Divisibility rule of 3 says sum of the digits should be divisible by 3. Then the number will be divisible by 3. Divisibility rule of 4 says that if the last two digit of given number is divisible by 4, then the number will be divisible by 4. In the same way, the 5 divisibility rule says that the last digit of any given number is 0 or 5, then the number will be divisible by 5. Divisibility rule of 6 says if the given number divisible by 2 and 3 both, then the number will be divisible by 6. In the same way, 7th divisibility rule says that double the last digit, subtract from the remaining number if the result must be divisible by 7 or result should be 0, so the number will be divisible by 7. 8th divisibility rule says that if in the given number, last 3 digit is divisible by 8, then the given number will be divisible by 8. 9 divisibility rule says that sum of the digit of the given number should be divisible by 9. 10 divisibility rule says that last digit should be of given number is 0. So the number will be divisible by 10. And 11 divisibility rule says that the difference between the sum of the digit in odd place and even place is 0 or divisible by 11. Next one is prime number and factorization. So prime number up to 100 we can calculate. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. So these are total 25 prime numbers up to 100. Now prime factorization. So breaking a number into its prime factor is called the prime factorization. As we know that any number, any composite number can be break into prime factors. For example, 24 we can break it into 2 into 2 into 2 into 3. So 2 is prime, 3 is prime. So we can write it 2 to the power 3 into 3 to the power 1. Same way 45 if we break it, we can write it 3 into 3 into 5, which is 3 square into 5 to the power 1 we can write it. Now the number of factors. So the question will ask in SSC CGL exams, find the number of factors. So if n having a to the power p into b to the power q into c to the power c, c to the power r, where a, b, c are prime factor of n and p, q, r represent the number of prime factors, then the total number of factors will become p plus 1 multiplying by q plus 1 multiplying by r plus 1. We get the total number of factors. And the next question asked by SSC CGL exams related to factor, which is sum of factor. So the formula will become a to the power p plus 1 minus 1 upon a minus 1 multiplying by b to the power q plus 1 minus 1 upon b minus 1 and so on. Now next one is D is SCF LCM. So we know that SCF is highest common factor. It means the largest number that can divide two or more numbers is called the highest common factor. LCM is the least common multiple. Smallest number which is divisible by two or more numbers. So formula become related to SCF SCF. So SCF multiplying by LCM, it should always equals to the product of given two numbers whose LCM SCF we take. Now we need to understand the SCF. So SCF, when we say that if we take two numbers as 12 and 15, so what will be the SCF? So the definition says that the largest number that divide two or more numbers, highest common factor. So what will be the highest common factor of these two numbers? A highest number which can divide these two numbers. So we can clearly see that 3 is the only number which can divide 12 and 15 also. No any other number which is more than 3 is can divide 12 and 15. Same way, if we need to calculate the LCM of 12 and 15, so what we get is smallest number divisible by two or more number. So what will be the number which will smallest number which will be divisible by 12 and 15 together? So when we calculate it, we got 60. 60 is the smallest number which is divisible by 12 and 15 together. Now unit digit and cyclicity. Now cyclicity table first we see. So this is the cyclicity table of the unit digit of a number. So if unit digit of any number is 0, so the cyclic pattern will be 0 and length will be 1, because we know that if we take 10 to the power 2 or 10 to the power 3, so why we choose 2 and 3? One is even power, one is odd power. There should be only two possibility, power should be or even or odd. So if we take power even, we get 100. If we take power odd, we again get 1000. It means at unit place we always get 0. So we can say that the cyclic pattern will be 0 and the cyclic length is only 1. It should be only 0 come at the unit place. Now we move to 1. So any possibility of 1 will become when the unit digit of any number is 1 and we take square or cube, we can do it. So what we get? 11 square, we know that 121. In the same way, 111 cube will become 1331. So what we get? When we take cube of 11, so what we get? We get 1331. Now we can clearly see that we get the 1 at the unit place always if we take the even number power or odd number power. So the cyclic pattern is 1 and cyclic length is 1. Now we move to 2. Now we know that the cyclicity of 2 is 4. How? When we take power 1, when we take power 2, when we take power 3, when we take power 4, and for example we take power 5. Now when power 1 we get unit place 2, when power 2 we get 4, when power 3 we get 8, when power 6 we got 6, and again when the power will become 5 times, so we get again 2. It means after 4 power, the unit digit of 2 is repeating itself. So we can say that the cyclic pattern is 2, 4, 8 and 6 and the cyclic length is 4. In the same way, when we do it with 3, we get the cyclic pattern which is 3, power 1, power 2, 9, power 3, 7 and power 4, 1 and cyclic length is 4. But when we move to 4 and 9, so their cyclicity is 2. They have only depend upon the power is even or odd. Even or odd. So if power is even, we got 6 at a unit place, and if power is odd, we got 4. In the same way, when power is even of 9, we got 1 as a unit place digit, and when power is odd, we get 9 as a unit place digit. So the cyclicity of 5 is 1 because we always get 5 at unit place. It doesn't matter power is even or odd. In the same way 6, we always get 6 at unit place. It doesn't matter power is even or odd. Now we can say that the 7 and 8 which having the cyclicity of 4 similar as 2 and 3. So when power 1 is 7, we got when power 2 is 9, when power is 3, we get 3, and when power is 4, we get 1, and when power repeating itself, so we get these number at unit place. In the same way in 8. Now finding the unit digit. So step 1, find the last digit of the base number. Step 2, divide the exponent by the cycle length and find the remainder. Third step is the unit digit is the remainder term in the tth term in the cycle. For example, find the unit digit of 7 to the power 24. Now we know that the cyclicity of 7 is 4. 7931. Length of cyclicity we know that 4. So when we divide the power 24 by 4, what we get remainder as a 0? It means the fourth term will be the unit place number. And we know that fourth place having 1. So the unit digit of this number will be 1. Now we move to remainder theorem. Next one. So when we solve the remainder theorem based questions, so first we need to basic remainder rules. So if n is divided by d, then we know that n equals to divisor multiplying by quotient plus remainder, where remainder will always be greater than or equals to 0 and less than to divisor. Now second one is in remainder theorem, Euler theorem. We need to learn If A and N are co-prime, then A to the power totient N equals to is congruent to 1 mod N, where totient N represent the Euler totient function. So we applying this to calculate the remainders. We also applying the Wilson theorem, which says that for a prime number P, P minus 1 factorial is congruent to minus 1 mod P. Same way, Chinese remainder theorem help to solve the simultaneous congruencies problems. So these are the basic important theorem of remainder theorem which we use to solve the questions of remainder. Now next one is surds and indices. So we need to learn the law of indices. For example, a to the power m into a to the power n, we can write it a to the power m plus n. Law of surds, so under root a into under root b, so what we can write? We can also write under root a b. Rationalization, removing roots from denominator is called the rationalization of the numbers. Number series and pattern, next one. So arithmetic progression based questions, geometric progression based questions, and special series, square, cube, triangular number. Next one is important formula and shortcuts. So sum of the square of first n natural number is n into n plus 1 into 2n plus 1 upon 6. Second one is sum of first n natural number is n into n plus 1 by 2. Next is sum of cubes of first n natural number is n into n plus 1 by 2 whole square. Next one is number of zeros in n factorial. So sum of n upon 5 plus n upon 25 plus n upon 125 up to when n become less than 1, the denominator. So we get the number of zeros. And the last one is divisibility by 7, 11 and 13. Check using 1001 rule, because we know that when we multiplying 7, 11 and 13, what we get? We get 1001. Next one. Now conclusion. So master divisibility rule, SCF LCM, unit digit, cyclicity and remainder theorem. Practice previous year SSC CGL questions for better understanding of this topic. Use shortcuts to save time in exam. Now we are moving to 10-day study plan for number system. So key focus areas in number system for SSC CGL. First we discuss about the key areas. So first is basics, types of number, divisibility rule, place value, face value, operations, for example SCF, LCM, remainder, fraction, decimals. Special topics like unit digit, cyclicity, divisibility, remainder theorem. Next one is advanced number of factors, sum of factors, trailing zero, binomial theorem applications based questions. Now we move to 10 days plan for preparing number system for SSC CGL exam. So day 1 we can do classification of number. So on the first day we can study natural number, whole number, integer, rational, irrational, prime, composite, co-prime numbers. Try to solve minimum 25 questions which are related to 10 practice question and 15 PYQs based on these properties. On day 2 we can do study divisibility rule. So we need to learn the divisibility rule up to from 2 to 13 with shortcuts, and try to solve minimum 30 questions in which 10 are the practice questions and 20 should be PYQs, and apply these rule of divisibility rule which you study on that day. On day 3, LCM and SCF. So understand how to calculate SCF, LCM and SCF, both basic and words problem, because SCF LCM question asked in SSC CGL exam mostly word based problems. So you need to understand the word problem of the number system, by which how we can applying the LCM and SCF in these type of questions. So solve minimum 25 questions, 10 practice question and 15 PYQs applying these concepts. On day 4 we can do fractions and decimals. So practice operations of fractions and decimal. For example, what we can do, operations we apply addition, subtraction, multiplication of division of the fractions number and decimals numbers. And try to solve minimum 25 question, in which 10 should be the practice question and 15 should be the PYQs, and applying these concepts which you learn on day 4. Fifth day you can learn unit digit and cyclicity of the numbers. So learn about how to calculate the unit digit and cyclicity of the number from 0 to 9. And try to solve minimum 25 question, in which 10 should be the practice question and 15 should be the PYQs on last digit and power cycle based questions. Sixth day you can learn about the remainder theorem. So understand the basic remainder theorem concept, learn Euler theorem, Wilson theorem, Chinese remainder theorem and apply it to the remainders problem. So solve minimum 30 question, in which 10 should be the practice question and 20 should be the PYQs which are asked in SSC CGL exam, and apply these concepts to solve these type of questions. On day 7th, factors and multiples of number. So you need to learn the factors, find the number of factors, sum of factors of a number. Solve minimum 30 question, in which 10 should be the practice question and 20 should be PYQs, and applying these concepts, factor and multiples. On day 8, you should study the trailing zeros and factorial numbers. So study how to calculate the trailing zeros in factorials and related problems, and how to calculate the number of zeros in factorial numbers, because question asked in these topics. So solve minimum 30 question, in which 10 should be the practice question and 20 should be the PYQs which are asked in SSC CGL exams, applying this concept. On day 9, number system conversion. So as we know that sometimes SSC asks the number conversion which are binary to decimal, binary to octal, binary to hexadecimal. So we need to learn about these conversions and try to solve 20 question, in which 10 should be the practice question and 10 should be the PYQs, applying these concepts. On day 10, revision and mixed practice. Because now you have completed all the topics of the number system, so on day 10 you should revise all the topics you studied in last 9 days and try to solve mixed question which are related to factors, number of zeros, divisibility rule based questions, unit digit based questions, number of zeros based questions. So try to solve these type of questions. Revise all brief topics briefly. Solve mixed problem covering all the above topics. Take a timed mock test on number system. So it is very important to take mock test and a given time frame, using the stopwatch to solve the question of the number system. Next one. Now additional tips for preparing SSC CGL exams. So that your daily routine should be morning routine. In morning you can read or study 2 hours for concept learning by using the NCERT books. Afternoon 1 hour for PYQs and shortcuts, and evening 1 hour for mock test and error log. And what should be in error log you can do? Maintain a mistake notebook for repeated error. For that you can try to understand why you are doing error many times in the same type of question, and try to understand the problem and remove your error in solving the questions. Now we will see some previous year example question which are asked related to these topics which are discussing previously. So here 10 or 15 most frequently asked PYQs, previous year questions from the number system topic in quantitative aptitude for SSC CGL exam. So first one is divisibility and remainder based question we will see. So what is the remainder 167 to the power 99 is divided by 7, and this question is asked in SSC CGL 2020 exam. Same way, when a number is divided by 56, the remainder is 29. What will be the remainder when the same number is divided by 8? So this should be based on the divisibility rule. First one is the remainder based and second is divisibility based question, which are asked in SSC CGL 2019 exam. Now we will see the question which are asked related to unit digit and cyclicity based question in previous year. So question is, what is the unit digit of 2467 to the power 153 plus 342 to the power 8, and this question is asked in SSC CGL exam 2018. Next one is the unit digit of in the unit place of 7 to the power 171 plus 3 to the power 71 is, and this question also asked in 2017 SSC CGL exam. Next one, LCM SCF based questions. So the LCM of two number is 12 times their SCF. The sum of LCM and SCF is also given, which is 403. One number is 93. Find the other number. And this question is asked in SSC CGL exam in 2021. Next one is the HCF of two number is 11 and their LCM is 693. If one number is 77, find the other number. And this question also asked in 2019 SSC CGL exam. Now we can say that both the question based on LCF and LCF concept. Now next one is fraction and decimal. So if 1.5 x equals to 0.04 y, then find the value of y minus x upon y plus x. And this question is asked in SSC CGL 2020. In the same way, the sum of the fraction and its reciprocal is 113 by 56. Find the fraction. And this question also asked in SSC CGL exam in 2018, which are based on fraction and decimals. Next one is number property, which are based even, odd, prime, composite based questions. So the sum of three consecutive odd number is always divisible by, and this question is asked in SSC CGL 2019 exam. Next one is the difference between two prime number is 2. What are they called? And this question is asked in SSC CGL exam in 2018. And these are based on the prime number property of the composite number, or prime number property, even odd based property of the numbers. So next one is number series and pattern. So find the missing number in the given series, and this question is asked in SSC CGL 2020 exam. Next one is find the next term in the series 3, 6, 11, 18 and 27, and this question also asked in 2019. Now in our new pattern, series question asked in reasoning topic. 7th is rational and irrational numbers based questions in previous year exam. So which of the following is irrational number, and this question is asked in SSC CGL 2021 exam. Same way, surds and indices based question. So question is, if 2 to the power x equals to 8 to the power y plus 1 and 9 to the power y equals to 3 to the power x minus 9, find the value of x plus y. And this question is asked in SSC CGL exam in 2020. Next question is simplifying 5 to the power n plus 2 minus 6 into 5 to the power n plus 1 upon 13 into 5 to the power n minus 2 into 5 to the power n plus 1. And this question also asked in SSC CGL exam in 2019. So these questions cover divisibility, remainder, SCF, LCM, unit digit, fraction, number series and surds, key areas frequently tested in SSC CGL exam. So practice these will strengthen your number system concept for the exam. Now the common mistakes you should avoid in the exam. So in the number system section of the quantitative aptitude for SSC CGL, students often make a common errors due to conceptual misunderstanding or calculation mistakes. Below are the most frequent mistakes along with the solution to avoid them. So first one is misidentifying prime number. For example, error is considering 1 as a prime number or missing composite number. For example, 91 we take it as a prime number, but we know that 91 is a composite number, 7 into 13. So the solution is remember prime number have exactly two distinct factors, 1 and itself. So 1 is neither prime nor composite. We also know that. So we need to memorize prime number up to minimum 50. So we will do less mistakes to solve the question. Next one is error in unit digit problems. So error what we did in the question. So incorrectly calculating the unit digit of large exponent. For example, if you need to calculate the unit digit of 7 to the power 245, so the student many times do the wrong calculation to calculate the unit digit. Now solution is learn the cyclicity of unit digit. You should remember the cyclicity of the numbers. Now we know that 2, 3, 7 have the cyclicity of 4, 4 and 9 having the cyclicity of 2, 0, 1, 5 and 6 always end with the same digit. For example, 7 to the power 4 has unit digit 1, because we know that the cyclicity of 7 is power 1 is 7, power 2 is 9, power 3 is 3 and power 4 is 1. So when power 4 we get the unit digit as a 1. So for 7 to the power 245, we divide the exponent by the 4 and we get the remainder 1. So we know that when power 1, what we get the unit digit? 7. So unit digit should be 7. Next one is confusing rational and irrational number. So confusion between rational and irrational numbers. So the error will be assuming 22 by 7 is irrational or misclassifying number like root 16. Now the solution is rational can be expressed as p by q. Example 0.5 root 9, because when we take the square root of 9 we get 3. So this is not a irrational number, this is a irrational number, and 0.5 we can write it 1 by 2. So both are rational number. Irrational number, those number which cannot be expressed into p by q form. So for example, root 2, pi, root 3, root 5, we cannot write it into p by q form. So that's why these numbers are called irrational numbers. Now 22 by 7 is a rational. It's an approximation of pi but not the pi itself. So next one is incorrect conversion of fraction to decimal or decimal to fraction. So error will be done by the student many times, misplacing decimal points or simplifying fractions incorrectly. So the solution is for recurring decimal use fraction conversion tricks. For example, 0.3 bar we can write it as a 1 by 3 and 0.12 bar we can write it as a 12 upon 99. So for terminating decimal, multiply divide by power of 10. Next one is misinterpretation of remainder theorem. So error is incorrectly applying the remainder concept. For example, 17 by 5 gives the remainder 2, but minus 17 by 5 gives the remainder 3. You need to understand that. Now see the solution. Remainder is always non-negative and less than divisor. So for negative number, adjust minus 17 dividing by 4, we got the remainder. When we dividing minus 4 with the remainder 3, since minus 17 is equals to 5 into minus 4 plus 3. So next one is the calculation error in large multiple or division. Now expected weightage of the number system in SSC CGL exam. So the number system is a crucial topic in quantitative aptitude section of the SSC CGL exams. Over the years, the weightage and the distribution of the questions from this topic have shown some trends. Now the typical mark distribution in number system in SSC CGL exams. So the average question per exam asked in SSC CGL is 1 to 2 out of 25 question in tier 1. And the average question per exam in mains tier 2 exam out of 30 is 2 to 3 questions. So mark allocation 4 to 6 in tier 1, 2 marks per question, and tier 1 in tier 1 also 0.5 mark from each wrong answer. And in tier 2 we get 3 mark per question and minus 1 mark for each wrong answer. And difficulty level mostly easy to moderate with a 1 to 2 tricky questions. So trend analysis of the last 5 years as we discussed. So we can say that in 2020 1 to 2 question asked and the paper is easy. Question asked related topics are factors, multiple and simplification based question. In 2021 1 to 2 question asked, moderate level questions asked, and question based on divisibility rule, prime numbers and simplification based question. In 2022 1 to 2 question asked, some paper only 1 questions and some papers 2 questions asked, and level was easy to moderate and question based on unit digit, fractions, number properties. In 2023 1 to 2 question asked in tier 1 exams. We are talking about tier 1 exams. So the level of the questions was moderate and the question based on SCF LCM, remainders and divisibility rule based question. And in the last year 2024 1 to 2 question asked and the question difficulty level was easy to moderate and question based on remainder, divisibility rule and simplification based questions. So most important subtopic weightage wise: LCM SCF 1 to 2 questions, divisibility rule 1 question, remainder theorem 1 question, unit digit and cyclicity based question 1, fraction and decimal based question 1, number property based 1 question, which are prime, composite, even, odd based question 1 question asked. Now key observation of the last 5-year trend analysis, we can observe it. Increasing focus on the application based question, for example word problem on LCM SCF. Remainder theorem and cyclicity are frequently asked. In tier 2 quantitative aptitude has slightly tougher question, sometime involving algebraic number system. So the preparation strategy: masters basic divisibility rule, prime, factorization, practice divisibility, SCF LCM, remainder problem and high probability. These are the high probability topics: divisibility, SCF LCM, remainder problems. Solve previous year paper, especially from 19 to 24. Thank you.